This will be for the con exercise, evaluate inverse functions. All right, some notes before we begin. Let's say you have a function, y equals f of x. The way you would designate the inverse function is like so. Okay, this is y equals inverse f of x. This -1 looks like an exponent, but it is not an exponent. All right, this -1 just refers to the inverse function. And for the inverse function, the x and y values are exchanged. Okay, so if the original function has a point at x equals 3 and y equals -5, the inverse function will be reversed, and the y value becomes the x value, and the x value becomes the y value. So this one here would be the original, okay? And this one here would be the inverse. All right, the graph of y equals h of x is the dashed green line segment shown below. Drag the endpoints of the solid segment to graph the inverse of y equals h of x. All right, so the original function is the dashed green line, and the solid is going to be the inverse. All right, so right here, the dashed green line is the original function. So what you want to do is get the coordinates of the endpoints. All right, for this point right here, the x coordinate is 7. And for this point, again, the y coordinate is -6. At the other end of this segment right here, the x coordinate is -2. And the y coordinate is right here between 0 and -2. This is -1. All right, so we have the coordinates of the endpoints. All we have to do is reverse or exchange those. So for the inverse, -6 on the y is going to be -6 on the x, and 7 on the x is going to be 7 on the y. All right, we just exchanged those 2 points. And same thing here for the inverse. -2 on the x is going to be -2 on the y. And -1 on the y is going to be -1 on the x. So again, all we did was exchange the x and y coordinates of the endpoints. And the final step is to plot these new coordinates. Okay, so at one endpoint, we're going to be at x equals -1, y equals -2. X equals -1, y equals -2. That's right there. And the other endpoint, x is -6, y equals 7. X is -6, and then y equals 7. It's right there. It's off the screen a little bit. All right, but this is 5, 6. This is 7 right here. All right, so y equals 7, x equals -6. We have our 2 endpoints. Let's grab the point here, left click and drag it right onto the point that I plotted. Okay, and the other point, same thing, endpoint, left click, hold it down, drag it into that point right there. All right, so that's it. Exchange the x and the y coordinates of the endpoints, get the new endpoints, and then plot those endpoints. So that's basically it. The graph of the invertible function h is shown on the grid below. All right. What is the value of inverse h of -1? So real quick, if we were to find h of -1, what you want to do is go to x equals -1, and then find the y coordinate. All right. So that would be if it was just h of negative 1. If they are asking for the inverse h of negative 1, you reverse these, okay? You want to go to y equals negative 1 and find the x coordinate. All right, so it's basically just the opposite of h of negative 1. This is inverse h of negative 1. All right, so we're going to go to y equals negative 1 and find the x coordinate. And whatever that is going to be the answer. All right, this is the y-axis. Y equals negative 1 is right here. Let's trace that to the graph right there. And the x-coordinate is right here. Okay, so it looks to me like the x-coordinate on the graph is negative 1. All right, in case you can't see it, we went to y equals negative 1, and this point on the graph at y equals negative 1, x equals positive 1. Okay, so that's what we want, the x coordinate. All right, the table below shows inputs and outputs of the invertible function f with domain all real numbers. Find the following values. All right, for both of these, what you want to do is evaluate the inner function first. All right, so the second one is actually a little easier, so I'm going to do that first. All right, so the inner function here is f of 7. What does that mean? That means you want to go to x equals 7 and find the y coordinate. Okay, so for f of 7, I go to x equals 7, and my y coordinate is negative 6. So I'm going to replace f of 7 with negative 6. All right, and now to evaluate f of negative 6, I basically just do the same thing. All right, I go to x equals negative 6 and find the y coordinate. All right, so let's do that. X equals negative 6, and the y coordinate is negative 15. So we got that out of the way. Next up, want to find inverse f of 93. We're going to do the inner function first. F of 93 means x equals 93 and y equals what? So let's go to x equals 93. All right, and we don't have it. All right, this is actually a trick question here, because what happens is, here we want to get the y coordinate at x equals 93. So let's say we get whatever y coordinate that is. And then here they are asking what is the x coordinate at that y coordinate. So that is just 93. All right. If you take the inverse of the original function at a point x, it will just return that value of x. Okay, so please write this in your notes as well. All right, if you take the inverse of the original function at point x, it will just return the same value of x. So right here, the inverse of f of 93 is just going to be 93, okay, even though it's not on the table. It's basically the inverse of the original function at a point x, which would be that same point x. All right, 93 and negative 15.